to this computer. Good. Yeah, we're moving. And okay, so do you remember? Can you remember this notation? Right? We're doing relative motion. Okay. And I came up with this notation that's rather easy to memorize, and even the notation itself has some mathematical properties, which is really nice. You got this is October 1st, 25, Wednesday, relative motion. Relative motion, okay? So I'm gonna write down the what the notation means, right? VBA means the following. Velocity of B with respect to A. Okay? That's what it means. Velocity of B with respect to A. A is the what the notation, the subscript that comes last is what the velocity and any other vectors are taking with respect to as an origin, right? That's what this notation means. And so following that approach, VA means velocity of B with respect to A. VAB means velocity of A with respect to B. And there is this, there is this nice mathematical property of this notation, right? Mathematical property of this notation, one of the mathematical properties of this notation is okay, is V B with respect to A is equal to minus VA with respect to B. There's a negative sign here. Okay. And now let's do one interesting example. We did examples of relative motion in the one-dimensional space. And now we are now going to do an example of relative motion in the two-dimensional space. Okay, here you go. Let me put another formula here, right? So it can be complete. And just as a reminder, if you want to calculate, for instance, the velocity or even the position of a point with respect to A and B, don't forget, this notation is good even for other vectors, right? Not just the vector velocity, but the vector position as well. Okay, so if you have the velocity of a point B with respect to a point A, you can find the velocity of this point B with respect to a referential A just by using that formula that's very easy to memorize, okay? Don't forget there's a plus sign here. And you will be able to solve this problem. And like I said, this type of knowledge has practical applications in real life. Okay, and one of them is if you are flying your airplane in the sky and you want to go from point A to point B, you have a strong wind that you have to negotiate with. You have to point your airplane in a proper direction. And the direction that you have to point the airplane is not necessarily towards the airport that you are flying to, okay? Because you have to correct for the wind. And that's a practical application. Another practical application is the case of a boat that's trying to cross a river. Okay, the boat must also be pointed in the proper direction to cross the river. And we're going to do this example. Okay, so in the previous class, we did the following. We did a very simple example of relative motion 1D. This example is so simple that we did not even need the formal equation of relative velocity. But we did use the relative velocity anyway, the relative velocity equation anyway, just to show to you that it does work, right? In the case of this problem, let's write that down, right? In the case of this problem, comma, we first did an analysis. We first solved it. We first solved it doing an analysis of the problem using illustrations, and then we solved in a different way. We solved in this case, in the case of this problem, we solved it in two different ways. In two different ways. One, first, by analyzing the problem using an illustration. And two, then by using the equation of relative motion. In both cases, the result was the same. In both cases, the result was the same, right? It has to be the same. Otherwise, either one or other method will be incorrect. Okay? Okay, so I can erase that part here. Now we solve a more difficult example in 2D using the vectorial equation of relative motion. Don't underestimate the power of this equation. It's very important for navigation. Whether you're flying an airplane, whether you're flying or whether you're using a boat in the ocean, open waters, or even the river. Okay, and okay, we have this example in the book. Again. They're blocking me. They're blocking me to use, and I know why. Let me see if I can fix that. Okay. Isn't that nice when we know how to fix a problem? Here you go, work it, right? Schedule a demo. Let's see, log in. Log in. Here's the book. and of course resources. Launch. Here you go. Here's an example for one-dimensional example, right? 1D. And here's the 2D example that I mentioned to you. Here's the 2D example that I mentioned to you. Okay. So if you're trying to cross a river using a boat, okay, and here we have this example that the boat is pointed 90 degrees with respect to the shore. If you keep on pointing this boat 90 degrees with respect to the shore, your boat is going to be carried downriver. Okay? Eventually you'll be able to cross the river, right? But the boat is going to be dragged downwards the river with the current. Suppose that you want to cross the river exactly to the opposite place, to the opposite point, okay? You start here and you end exactly right there, right? If you're again, if you're pointing, if you start here and point the boat straight forward, you're going to end up in this other point here of the river. It's not going to be right in the front of it because you have to deal with the velocity of the current. This is a relative motion problem. Okay, so if you want to cross the river and end up exactly on the opposite side of the riverbank, let's see if you have an illustration here. Should be he doesn't have it. I thought he had it. Okay, so I just tell you what you have to do. You have to counter the current by pointing the boat to a little bit to the left. Okay, a little bit to the left. If you do that, and you have to have the proper angle, right? That depends on your velocity. If you do that, you will cross the river to exactly the opposite point of the riverbank. Okay, so let's write that down. Okay, now let's see if I have an illustration here. Oh. Used to have an illustration of this problem. Huh, I don't have an illustration. That's odd. Let's see if it's here. Yeah, it looks like I'll have to do from scratch. What a shame. It's gonna take me a long time to do that. Uniform circular motion. Let's see. Yeah, let's see if I can do that for you. It's gonna take a little bit long, but we will do it. I'll need the axis, right? And yeah, I'll need those two here. That's going to be the ground referential, the riverbank referential. Okay, that's gonna, I call that referential A. Let me eliminate that. I want to make it a little bit thicker. Okay, let's see if we have, yeah. Make sure, yeah, it's horizontal, right? Let's see, make sure this one is vertical. There you go. And then I will call this one the origin O. The origin O. Let's see, on this coinciding with the x-axis, we have the riverbank. And a little bit up along the y-axis, we have the other riverbank. Okay? So let's say, that's the north, south, east, and west. That's the south riverbank. I'm gonna put here the just for orientation purposes. Okay, north, south. Position, rotation, I'm gonna rotate it 90 degrees, good. Now we're gonna have east-west, okay? Here's the northern direction. So let's say the river, here the northern portion of the river bank, that's the southern portion of the river bank. South, that's east. And this other one is west. Okay? Differential A, let's put a little bit more to the right. What else do you have? No, we are going to have another referential, which is moving with respect to the riverbed referential. The riverbed referential is just the ground referential, and I'm going to change its color to black. Referential B, and that this other referential B is the referential of the water current that's moving. Okay, moving from towards the east. And I'm going to get the relative vector velocity of this referential right in here, right? Let me put that a black color as well, make it thicker to look nice. And instead of VPA, I'm gonna call it VBA, right? Velocity of referential B with respect to the referential A. And one more thing here that I did, instead of a black color, I'm going to put a red color for the referential A, right? This one's gonna be referential A as well, so it's gonna be the red color. And now I will duplicate those two to label. differential B. And I'm gonna put them in black color. Not just a black color, but I'm gonna do something else too. I'm gonna change the name of the referential. Instead of Y, I'm gonna use Y prime. Instead of X, I'm gonna use X prime. Oops. X prime, like that. That's the referential of the water current. Okay. Save it. Now I'm gonna draw my boat. Here's my boat. I'm gonna draw it as though it is a rocket ship. All right. Here you go. My boat is right here. Yeah, good. Like I said before, if my boat keeps pointed, and don't forget, what I mean by my boat keeps on pointed in this direction, it means that its velocity vector is going to be pointed, right, in this direction towards the north. Velocity, and that's going to be velocity of my boat is going to be my point P, okay? My point P with respect to referential A is pointed towards the north. We're doing just the qualitative treatment of this problem right now. And then we're going to get into the quantitative treatment. View, grid line. If it's pointed towards this direction, what's going to happen? You know, a little bit later, this boat is going to be, yeah, a little bit towards the center of the river, right? But it's also going to be dragged 1, 2, 3, 4, 5, 6, 7, 8 down the stream, downstream, okay? Downstream is to the right, upstream is to the left. So here you go. If initially the boat is here, a little bit later it's going to be here. Okay? That's what and then the relative velocity of the boat is going to be, you know, pointed a little bit to the right. Okay? I have it here. Okay. For some reason, I couldn't find that. I have here in my notes. That's okay. 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 By the way, this velocity vector here is not VP of sub A, but VP with respect to B. Okay. With respect to B. It's not VP with respect to A, but VP with respect to B. The velocity vector of the boat makes a 90 degrees with the velocity vector of the water stream. So let's play the movie again. You know, here you go. 1/3, another. Oh, here you go. The boat is going to continue moving down the stream, but also is going to advance a little bit more towards the other margin. Okay, and I'm gonna put it here. Margin of the river. margin, northern margin of the river, northern. And I'm gonna put it in black color here, southern margin of the river. I'm gonna put that on the other slides as well, right? Here we go, this one and this one. So let's play the movie again. My boat is advancing towards the other side of the river, right? Here we go. That's I exaggerated, right? Let's see. Oh, 1, 2, 3. I exaggerated. Let's make it a little bit more to the left. Okay. And I'm assuming that the velocity is constant. Okay, I'm assuming the velocity of the boat is constant. And what else? In the next slide is going to be something like that. 1, 2, 3, 4. Yeah, oops. I gotta make this one a little bit more to the right? Otherwise, it's gonna feel just like a little wimpy. Here you go. 1, 2, 3, 4, right? That's what happens whenever you point your boat in the wrong direction, right? So here you go. I'm gonna put a point of reference here as well. So here you go. We start writing here. Next, here you go. Next, oops. Next, right? So here you go. So the displacement vector of this boat, what was the displacement vector of this boat? I'm taking that the back of the boat, right? Which is going to be roughly in the northeastern direction. That's the displacement vector of your boat. Assuming that the riverbed didn't change its, that the river stream didn't change its speed. Assuming, right, the boat didn't change the speed. Okay, delta, I'm gonna put it here, delta R from this point to the other point. Displacement of the, it's not BA, but displacement of both P with respect to referential A, which, by the way, is going to be parallel to the velocity vector of the boat P with respect to the O. Referential, oh man, I erased it. Yeah, I don't want to erase it. Here you go. Parallel to, that's the relative velocity of the boat, right? It's gonna be something like that. Did you get the idea? Right, that's a simpler problem. That's a simpler problem. And I will copy that. Oh, and let's not forget one more thing too, right? that I didn't do here. I didn't make the referential move to the right, huh? Let's make the referential move to the right. Yeah, let's make that's one more thing that's missing here in my drawing. Let's see if I got it right. I'm gonna put a reference here to make sure everything is being taken, is being, drawn in a realistic fashion, right? So here you go. So I gotta move my referential a little bit more to the right. Yeah, good. In the next slide, no, I should be able to draw my referential a little bit more to the right again, right? Here you go. The boat is moving with the river stream. Okay, I don't need that anymore. Let's see, one more. Move it. Yo, yo, yo. Here you go. Am I okay here? Let's see if I'm okay here. Yeah. Yeah. Okay, now I can take out this reference here. Yeah, that was the only thing that was missing was my, and if I want to, I can, come up with with my vector position as time goes by, right? Here you go. That's my vector position here. That's my other vector position here. Right? As time goes by, this vector position increases. Here you go. Oh, 4 frames. My movie has 4 frames. And now, okay, let's do an example. Now we'll solve a more difficult problem into D using the vectorial equation of relative motion. Don't underestimate the power of this equation, right? It's very important for navigation. Okay. So okay, so example. You are, and so I did that. I just did the qualitative treatment of this problem. Now let's try to do the quantitative treatment of this problem, right? You're trying to cross a river from its southern margin to its northern margin. Trying to cross a river. You want to cross a river, right? You want to cross a river from its southern margin to its northern margin. You know the water stream runs in the eastern direction. Eastern direction. Eastern direction. That's gonna be the velocity given by the velocity vector VBA. As you cross the river, comma, you keep your boat pointed towards the northern direction. What does it mean? Resulting in a 90-degree angle with the first vector, or, VPA, P refers to the boat, VPA, no, VPB, P refers to the boat, right? I'm gonna put now everything in black, so I don't have to worry about colors. Font, color, no color, huh? Yeah, or VPB makes a 90-degree angle with VBA. You want to cross a river from its southern margin to its northern margin. You know that water stream runs in the eastern direction and is given by the velocity vector VB with respect to A, right? A is the ground referential. A is the ground referential. B is the streaming referential. And P is your boat, or the referential of your boat. Assuming all velocity vectors remain constant during the crossing, right? Comma, find the velocity vector of P with respect to the ground. Okay? Solution. Okay, so solution. What do you know? You know VBA, you know the velocity of the stream. You want to put it exclamation mark. You know the relative velocity of your boat with respect to the stream, exclamation point, and what you don't know, right? And you want to find out is the relative velocity of your boat with respect to the ground. Here you go, with respect to the ground. I want to change this color here. Let's see if I can do that. Yeah, now I found it. Good. This one, everything here. Here you go. Everything here. And I don't want that. I don't want both faced here. Okay, that's what we want. Just refer to the equation that we did before, right? Okay, so the equation that we had before, let us copy it. Here you go, it's this one here. This one here. Everything black. Velocity of the point P with respect to A is going to be equal to that. Okay? And we can go even a step further. Okay, we can go because we know more about VPB and VBA, right? We know that VPB points in the positive X direction, which is the eastern direction. So let's do that. Let's do here you go. If it points in the positive X direction, I can put that notation magnitude of this vector, right? Magnitude of this vector is a scalar. Oh, hey, wait a minute. VP, is that right? Yeah, that's right. Okay. And we also know, let's see. Oh, no, sorry. It's not y hat. Y hat is the other one, right? This y hat is the other one. This one is going to be x hat is the other one. This one could be the y hat, the northern direction. Going back here to my, yeah, see that? Is the northern direction. And now the other one is going to be the x hat direction. PA x hat direction. Both are positive, are in the positive x hat and y hat direction. Okay? And now we can start using some numerical examples, right? So use the following numerical example. Let's say velocity or speed of the water stream is 4 meters per second. 4 meters per second, right? The water stream would be this one here. Yeah, I go. Should be A, not B. Yeah, use the following numerical example. And this one here, the relative speed of the boat with respect to the river, right? Let's say, you know, how fast a boat can go. Depends on the boat, right? If it's a speeding boat, it can go very fast. Let's put 8 meters per second. Mhm. Let's see. Solution, that's our solution. So let's put another example. Okay, referring to the above problem, referring to the above problem, comma, use the following numerical example. Use the following numerical example and find the speed. Let's see, I made a mistake here again. Let's see here. Ay, 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 ay. Man, I'm making too many mistakes here. Here you go, B is here, man. Nobody picked that up, right? Here you go. Okay, this one should be B. Yeah, this one should be B. Let me put in the proper order. Yeah. P P A A B B. P P A A B B. Okay, good. So how can I determine this speed, right? In the practical sense, how can I determine this speed here, the relative speed of the boat with respect to the river? Okay, there is a practical way of determining this speed. All you have to do is to get your boat and put, for instance, at a lake where the waters are calm. There is no stream whatsoever, and then put a determined power, a given power in your engine, and then you measure the speed in that calm water, right? That will be the speed of the boat with respect to the ground, but it also will be the speed of the boat with respect to the calm water. Okay? With respect to the calm water. That's what this speed is all about, is the speed of the boat with respect to a waterbed that's not streaming. Okay, that's how you measure that in practice. You put that in a lake, for instance. Okay, refer to the above, use the following numerical example and find the speed and the vector velocity of the boat with respect to the ground. Okay. Referring to the above problem, find the speed and velocity and the vector velocity of the boat with respect to the ground using the following numerical example, like that. Okay? So here you go. Solution. Solution, here you go. That's gonna be the velocity vector of the boat with respect to the ground, right? 8 meters per second here. Let's go another step. 8 meters per second here. 4 meters per second here. Like that. Now, if I want to get the speed, all I have to do here is to get the magnitude. Let me use this one here. So I don't need the use the straight bracket. Here is gonna be VP of A, right? Is going to be the square root of 8 square plus 4 square. 64 plus 60. What do we get? 64 plus 16 is going to be 80, right? Yeah, 80. Should be square root of 80. And don't forget the meters per second. meters per second. It's 8.9, almost 9, approximately 8.9. 8.9 meters per second. And what's going to be the direction of the velocity vector, right? With the ground, use the following example. And first of all, find the speed and the direction of the velocity vector. And the let's see, and the angle, right? And the angle, the velocity vector makes with the margin of velocity vector of the boat makes with the margin of the river. The speed of the boat, find the speed of the boat, the speed and the angle, the speed and angle, the velocity vector of the boat, the velocity vector boat with respect to the ground, makes with the margin of the river. Use the following numerical example. Okay? And now this angle is going to be going back right in here, right? Here you go. This angle is going to be this one right in here. Okay, it's going to be the y component divided by the x component. The y component divided by the x component is going to be the tangent. Tangent of this angle. Looking at the drawing, right? At the drawing and the resulting vector, comma, the angle will be the following. Tangent of theta is going to be 8 meters per second divided by 4 meters per second. The tangent is a unit that has no unit whatsoever. For this reason, the meters per second must cancel. The meters per second upstairs must cancel the meters per second downstairs. And for this specific example, we get 2, right? And let's see how much is that is. How many degrees this actually is. Check register, that's not what I want. I don't want that either. Let's see. I want another file. Must be this one. Let's see. Yeah, that's the one here. Let's see. We want arc tangent of 2, right? Arc tangent, a tangent of 2. But let's not forget. Oh, gotta put it in numeric format. Yeah, but that's 1.1 radians, right? I want in degrees. 1.1 radians is 63 degrees. 63.43 degrees. Okay. Arctangent of 263 degrees, 0.43. 62 degrees, 0.43. Raise. Oh, not what I want. Huh. would I raise that to the power? Huh. Strange. That what 63.43 degrees. That's what the arctangent of 2 is all about. You get an idea? And then you can do, and now I want you to do on your own, right? Example 3, example 1, example 2, example 3. Do it on your own. Repeat this problem for the case in which you want to cross the river to the exact opposite margin. Okay? And again, I'm just gonna do the qualitative, right? Qualitative way of the qualitative solution of this one, and it goes like that. What do you want? You want did I put VPA? Wait a minute, I have so many things wrong here. Yeah, so gosh, nobody told me that, huh? It's VPB, okay? Folks, here's VPB. VPB. Oh, I put VPB here. I just didn't correct the other one. Okay, that's good. Okay. This one is something else. This one is something else. Okay. Now, this one is the case in which the final VPA is towards the northern direction, right? In order to get the VPA in the northern direction, let me see, group. The VPB must be slightly to the left, it's slightly to the west, okay? I'm gonna put it here, here you go. VPA, right? That's the final velocity vector to the other side of the margin. And your VPB must be pointing slightly to the west. Like that. Because this component here, this horizontal component here of VPB must cancel this component here of the riverbed, right? Did you get the idea? So when you point their boat properly in the proper direction, what's going to happen? I'm gonna add a blank slide here so you know it's a different example. Okay? You know it's a different example. Here you go. A little bit later, your referential 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you go, 10. Your referential is moved a little bit to the right, right? Again, I am assuming those 3, 4, 6, 7. Let's see. I'm gonna go faster than that. Here you go, like that. Good. But I do not want encroaching, right? Don't want that encroaching with the like that. I'm gonna use that as a reference. Let's say Referential is moving with constant velocity, right? This guy, you go, water stream. Next, I'm gonna need that a little bit to the right. Right? My third slide is gonna be like that. Again, I don't want the thing approaching with the other one. Because it's lots of work to do that. It's not difficult work, it just takes time. Like that. I want my VP, okay, my VBA stays there, stays here, right? And let's not forget, this horizontal component must cancel this one for the object to move like that, right? For the boat to move like that. Another one, another slide. And now I'm doing the drawing in the most realistic way possible, right? So here you go. The most realistic way that's possible. Like that. Now I don't need that anymore. I don't need that anymore. I don't need that anymore. And then I can play the movie. Here you go. 1, 2, 3. Oh, I gotta move a little bit upwards. I didn't do that. He finally reaches the other margin of the river, right? So here you go. I adjusted the axis, but I didn't adjust this one gonna be a little bit here to the right. This one, yeah, like that. And now I can play the movie again. Here you go. First frame, second frame, third frame, final frame, like that. Okay. And then what I want you to do, repeat the above, right? I repeat the above problem, the above two problems for the case in which you want to cross the river to the exact opposite margin. Okay, already did that in a qualitative fashion, and you should be able to finish this problem up numerically. And to help you out again, I'm going to, no, I'm not going to do that. The numbers are different. Yeah, but you can consult, right, the previous notes of fall 2024 because I solved this other problem then. And it's is 10:48 right now. I want to ask you folks if everybody has a group before we go into the break. Does everybody has a group? Right? There are a few students that I understand they don't have a group yet. If you don't have a group, let me know. Do you have a group? Let's see. Jawaira, you have a group, right? Jawaira, yeah, Jawaira has group number 2. If you don't say anything, I'm going to presume that you have a group. 1, 2, 3. Okay. Okay, so let's go for our little break. Okay. 2024 break. Good. So now we are done from 10:49 a.m. Oh, let's put 50 here. To 11:05 a.m. Okay, and now we are done with chapter 3. Okay. Let's see, we have one more minute here. Let me get the list, the chapters, the sections that we covered so far. So we are in a nice position, neat, organized position here. Okay, here you go. Chapter 1. Chapter 1. 250. I'll finish that after the break. I'm taking too long. It's already 250. Let's see. Oh, here you go. I got it. Chapter 2. That what we are going to need for the exam. We finished chapter 3, but chapter 3 is not going to show up in the exam, right? And I'll tell you more about the topics for the exam, okay? After the break. I see you in 15 minutes. Okay, I'm back here. Okay, here's the topics for the exam. And let's not forget lab 1 as well, right? Lab 1, which includes significant figures. Yes, if we okay, Princess, yes, if we finish today, yes, the lab is going to be due next week, okay? Let's finish that first. I think we can finish it today. And let's say significant figures. What else? I'm sharing the screen, right? And CL, confidence level. Confidence level, resolution of the ruler, vernier caliper, and micrometer. It's okay, etc. Right? That's what we covered. Let's see. Oh, by the way, this thing doesn't show up in the exam, right? Because it's vectors. Let's see. Nature of physics units, the role of units, the problem solving, trigonometry, scalar, and vector. Okay, this part here doesn't include. Well, how am I gonna do that for the exam? For the exam next week. I'm going to move this one upstairs here. Nature, yes. Role of units, trigonometry. Okay, not this part, right? That would be for the exam number 2. Cool. Okay.
Wait, Professor, I had a question.
Yeah.
So, you said for lab 1, it's definite that it's due next Wednesday on the day of the exam.
Oh yeah, good point. Yeah, okay. Let's if we finish today, it's not gonna be due for the exam. It's gonna be due the other week, okay? So
Oh, the
you
week after the
yeah,
exam?
yeah, after the exam will be 2 weeks from now.
Oh, okay.
Okay, so yeah, we should expect to finish the lab today, and then you're gonna have like 2 weeks. Next
Okay.
lab meeting. Next lab meeting,
Okay.
you can turn on the spreadsheet.
Thank you.
Let's get let's see where we stopped in lab one. Lab one continuation. We stopped. Here you go. Here are the resolutions, right? Rule of multiplication. We were doing rule of the significant figures for multiplication and division.
Professor, I have a question about the lab.
Yeah, go ahead.
So in table three, sorry, right above table three, it says that we're supposed to plot the mass in the y-axis and the volume in the x-axis, but
Yeah.
on the graph for the ruler, it's the other way. So the volume is on the y-axis and the mass is on the x-axis.
No,
Is
no,
that
no. For all the three graphs, the mass is in the y-axis and the volume in the x-axis. All three graphs.
okay?
Okay, all three graphs. So let's get the spreadsheets here. Raw data, lab one. I was using this one here. So let's get this. Everybody has a group, right? So I want to make sure everybody has a group. Let me take attendance just to make sure everybody knows what they're doing. Sort. Okay, Eric Alcala, are you there, Eric?
Here.
Okay, so October 1st. Eric is here. Edith, are you there?
Yes, I'm here, Professor.
Okay, thank you.
Professor, I have a
Ah,
question.
yeah.
On the 24th, I think, marked absent, but I was here.
Uh-huh. Okay, let me take it here. 24 was last week. Okay, now let's see. Jawaida is here, right?
Present. Yeah.
Okay. Let's see. Well, I'm just interested in find out if there is anybody who doesn't have a group. So I'm gonna go just through those students who don't have a group. Miasia, are you there? And everybody else, let's see. This is what I want. Miasia is not here, right? Right. Yeah, not here. Who else? Simone Cato. I don't see Simone in my list. Who else? Arturo Lagunas. Arturo, I don't see him. Jenia Tapia. Oops. Yeah, I don't see that Jenia either. Okay, so let's organize it in a different way. Anybody else? Simone, okay. Okay, so everybody else should have a group. Now let's go here. So here you go. you have to plot the mass against the volume of the ruler, right? Plot second graph, mass against the volume obtained with the vernier caliper, and a third graph, mass against the volume obtained with the micrometer. Three different graphs that you have to plot. And the slope you're going to log right in here in this last table. Don't forget to put the units of the slope as well. Don't forget to put the units of the slope. And what else do we have to do? Okay. And I'm going this one here. Lab 1. Insert page break. Lab 1. Continuation. Continuation 2. Like that. Okay, so 1. Plot M along the y-axis and V along the x-axis for the ruler, vernier caliper, and micrometer. Total of 3 graphs. Total of 3 graphs. 2. Log the slopes of each graph in their respective in table 4. In table 4, table 0-4 are their respective cells, right? Like that. What else you have to do? Well, I usually like to tell my students after doing that, the priority is in our lab will always be to plot the graph. That's what are going to be the priorities, right? The first thing that we do in the lab is to plot the graph. Then you log the slopes of each graph into the table to see the percentage difference. And the next thing that you do, fill up all the units. Okay? Fill up all the units in their respective cells. 4. Takes time, a little bit of time, okay? And let's see, next. Work on the significant figures. Work on the significant, let's see, not work, display, right? Display the proper significant figures in tables. What tables? Let's see. Just in this table, just in the main table. You don't have to worry about significant figures elsewhere, but just here. Okay? Yeah. In every cell of table 0-2. Display the proper in every cell of table 0-2. And I mentioned what should be the resolution for each measurement, right? And I didn't mention, I didn't mention the resolution of the scale. Okay, so let's, oh yeah, I did mention right here. Let me put in table format. Okay, and you'll be able to do for the table as well. Here you go. Oh, not what I want. Go back there. That's the table I want. Instrument, ruler, vernier caliper, micrometer, scale. Scale, what's gonna be the resolution of the scale? The scale is gonna be, but then we are going to have, we are gonna have, okay, let's put the units elsewhere. We don't wanna put the unit here. Here the unit is gonna be in meter, right? The unit in meter. The unit in meter. And here the unit initially in grams, right? Let's put it, but so it should be 0.01 grams, but we want to display the unit in the proper main unit of the SI system of units. 1, 2, 3. So I sum three more three decimal places. And the measurements should be reported up to the 5th decimal place. 1, 2, 3, 4, 5. And I will bold face that, bold face that. Yo, bold face that. So with this information, you will be able to display your measurements, not just your measurements, but also your results, okay? With the above table, you will be able to display the measurements and the results with the proper significant figures. You will be able to proper significant. What else? 1, 2, 3, 4, 5. And let's not forget for significant figures, all you have to worry about is this table here. Okay. And finally, the final thing that you have to do is to fill up this second table, the table 0-3. 5, fill up table 0-3. Okay, what you have to do then? 1, number of pairs of data points, and number of data points in your graph. In your graph would be n. Regression equation would be what? Capital M equal to whatever, right? Yeah. And then R square value. R square value. And then, okay, what else? CL. Lower bound, upper bound. That's all you have to do for this lab. Just a reminder. Number of significant figures for the volume is given by the number of significant figures. The number of significant figures for the volume coincides, right? Here you go. Coincide with the number of significant figures for the diameter, for the measured diameter. Measured diameter. So let me see how you're doing. I'm gonna go through one by one and see how you're doing in this report. Okay. So let us start with the graphs, right? Let's see. Eric, did you plot out the 3 graphs? 1, 2, 3?
Yes.
Yes, all the 3 graphs. Any questions about them?
No, not really.
Okay. What about table 0-4? Did you log in the slopes?
No, not yet.
Not yet? Okay, so 0-4, this one right in here. Okay, so go ahead, log the slopes, and then let me know what's the percentage difference, okay? Now let's go edit. Did you do all the 3 graphs?
Not yet.
Not yet? Okay, so make sure you plot all 3 graphs, please. Okay, did you do anything else?
No, I only started on one of them
Okay.
so far.
Okay, so let's go to Jawaira. Are you there, Jawaira? Did you plot all the 3 graphs?
No, I haven't done the chat.
You're breaking up. Did you say yes or no?
I said no. I haven't gotten a chance.
Okay, thank you. Okay, let's go to the next one. Arwa, Paris, you plot all the 3 graphs?
No, I haven't done it yet.
Okay, so take the chance to plot them all. You need them. Next one is Catherine. Catherine is not here. Oh, no, Catherine, let's see. Yeah, Catherine is not here. Ben Bandoy. You plot all the 3 graphs, Ben? Let's see. Yes, okay, good. Did you enter the slope values in table 0-4? Yes, okay. Okay, so which one, how much percentage difference did you get for each one, right? There was 3 results, 3 different measurements, right? What was the percentage differences that you got for each of them? I'm gonna put it here, percentage difference. 1.02 should be for the ruler, right? 0.99, okay. 0.99. Okay, they're all less than 1%. Okay, thank you. So now happened here. Okay, so okay, now you gotta work. Did you work also on the units of units of each measurement and result? Ben, units right here. No, okay. So start working on that. Let's go to Melissa.
I'm
Are you
here.
okay? Good. Did you plot all the three graphs, Melissa?
No, not yet.
Okay. Did you plot at least one of them?
Not, I haven't had the time. I'm gonna do it today.
Okay. So let's go to the next Delisha. Let's see Delisha. I don't see Delisha here, right? Okay. Delisha. Next, Isabel Medina. I don't see Isabel either. Next is Queen Castaneda.
Hello.
Okay, did you plot all three?
I plotted in one of the graphs. I
Uh-huh.
still two.
Okay. Okay, good. And so plot the other two. Did you manage to also log the slope in the last table of this single graph?
No.
No? Okay. Okay, so let's work on the other two and then I'll get back to you. Next is going to be Emily.
Yeah, I plotted one of the graphs, but I still need to work on the other two.
Okay, good. So let's go. Gabriela, are you there? I don't see Gabriela here. Let's see, Carlo Gallardo. You plot
Yes, I plotted all three.
all three? Okay, good. So I'm gonna put a yes here. Did you log the three slopes in the last step?
No, I just need to plug it in.
Okay, good. So I'll get back to you later on, asking the percentage difference. So Angelica Franco, did you plot the three graphs?
Yes.
Okay, that's good. Did you log the slopes?
Yes. So
Yeah.
for the ruler, the percent difference is 0.66.
Uh-huh.
And then for vernier caliper, it's 1.84.
84.
And for micrometer, it's 3.77.
3.7. Okay. Unusual. Oh, but that's okay. Thank you. Did you start working on the units already, Angelica?
I was actually confused about that.
Uh-huh.
So I understand that for percent difference, I mean, yeah, for percent difference, the units are percentage.
Yeah, that's right.
And then for slope, what are we supposed to do to find the units? Isn't that just
The slope is
meters
supposed
cubed?
the slope is supposed to be what, right? What the how do you let's take a look here. The slope is what? The rise over the run, right?
Yes.
Okay, the rise over the run. What's the unit of the rise? What's the unit that is in the vertical direction? I'm giving you a hint here. What do you plot in the vertical direction?
The E and like what's in that column?
Here you go. What do you plot in the vertical
Oh,
direction?
kilograms. Oh, it's
Okay.
yeah.
Yeah. The unit of what you plot in the vertical direction is kilograms. What's the unit of you plot in the horizontal direction? What's the unit that you plot in the horizontal direction? What are you plotting, right, in the horizontal direction?
Micrometers?
Oh, you're plotting the volume, right?
Oh.
That is what you are plotting. What's the unit of the volume? What's the unit of the volume?
Meters?
The unit of the diameter is meter. The unit of the volume is going to be what? You gotta do the, how do you call it? Dimensional analysis, right? Dimensional analysis. Think about that. Go back to the equation. What's the equation for the volume? What's the equation for the volume? You already, here you go. Not this one. This one that I want. Here you go. The equation for the volume. I'm going to write it down here for you. The equation for the volume is 4/3 of what? Volume of the sphere, right? 4/3 pi. What else? Should be what? Diameter divided by 2, which is the radius, right? Raised to the cube, right? Now you do dimensional analysis of this equation. If the diameter is in meter and the meter is raised to the 3rd power, the unit of the diameter or the volume is going to be what? Okay, I'll leave like that. Think about that. Okay, so it's going to be the unit of the slope is going to be the unit of the mass divided by the unit of the volume. That's what going to be the unit of the slope. Unit, okay, of the slope. Unit of the mass. Unit of the mass divided by unit of volume, like that. So you have to know the unit of the mass and you have to know the unit of the volume to find the unit of the slope. If you do not know one of those units, you won't be able to find the unit of the slope. Okay? So let's go for the next one. Units, I'm gonna put it. No, next is gonna be Princess. Hi, Princess. Did you plot all the 3 graphs?
No, but I plotted 2 out of the 3.
Okay, that's good. Okay, once you're done, make sure you put the percentage differences, right? Find out the percentage differences that you're getting. Now, let's see, Brandon, are you there? Did you plot all the 3 graphs, Brandon? I see Brandon is here, but he's not answering. Is he answering? Let's see. Yeah, it looks like he is. Professor, I have an emergency. Okay, Kimberly. Oh yeah, is Kimberly? Remember, we are not using centimeters, right? In the lab, we are using the main SI unit, okay? And the main SI units are what? The main SI unit, the meter, the kilogram, and the seconds, right? That's just a comment on the point that you made there in the chat box, okay, Kimberly? So the correct unit should be combined with the kilogram and the cubic meter, right? Let's see. Okay, good. So, Carlo, did you? No, Carlo, I already talked to Carlo, right? I talked to Princess. Let's see. Carlo, yes, I talked to Carlo. I talked to Angelica. Brandon, I haven't heard from Brandon. Hi, Brandon, are you there? I'm gonna put a star under his name. Star here that Brandon Guerrero, right? Janie Maldonado. Hi, Janie.
Yes, I did plot mine.
All the 3?
Yes.
Okay, good. So what about the percentage differences that you're getting? What are you getting for the percentage differences?
One of them is really high. It's 26.58 for the ruler.
For the ruler, okay.
For the caliper, got 2.86, and then the micrometer is 3.74.
3.74, okay. Let's see, you're group number 8. Let's see. Sometimes we do get those high values for the percentage difference. And, and for the ruler, yeah, I would expect to get a high value. 30% looks like a little bit too much. Let's see if maybe there is a outlier. That's group 8, right? Let's see here.
Yes, group 8.
And that's that's for the ruler. Trend line display. I'm getting 9182 62 9162. What is the density of steel? Should be around 8,000, right? 9162. I'm not getting 20%. I'm getting less. Format cell. Let's see number.
Let me see, maybe.
It looks like you made a mistake there. Okay. I'm getting 9162. And what is the density of steel in the internet? Density of steel in kilogram per cubic meter. Between 7,750, yeah, 8,000. That's okay. 7,900, right? 7,900. Let's put 7,900 here. So I'm not getting 30%. I'm getting 16%. See that? See what?
Yeah.
Did you find out what was the problem?
Yes, let me go ahead and double check my chart again, and then maybe I did something wrong. I'll check. Thank you.
Okay. Okay, so I'll get back to you. Let me put bold faced here. And next, Kimberly Morales. Did you plot all the 3 graphs, Kimberly? I have only plot 2. Okay. Okay, good. Once you're done plotting all the 3, don't forget to log the percentage difference in the last table. Okay. Montserrat doesn't look like she's here. Doesn't look like Montserrat is here. Oh, and Nicolas Rivera. I don't see Nicolas either. Jason Surveillon. Hello, Jason. Did you plot all 3 graphs? I can't hear you, Jason. If you're talking, I cannot hear you.
I have plotted 2 graphs.
2. Okay. Okay, good. So take the time to plot the 3rd one, right? And after that, log the slopes in the last table.
Okay, thank you.
Welcome. So here goes Sydney Hill. Kimberly. Is Sydney Hill here? No, Sydney is not here. Next, Armand Taef.
I'm here. Yeah, I drafted two graphs.
2 graphs. Okay, so
And also the first class I was here and it says 0, but I was here.
Okay. Let's put that here. Juan Torres Arellano, did you plot your graph? Your 3 graphs one? Let's see. I am not here. I cannot hear from you. Let's see. 2. Okay, good. Thank you, Juan. Cecilia Chavez, did you plot all 3 graphs?
Hi, good morning. Yeah, I did all 3 graphs.
Okay, what's the percentage difference did you get for them?
For the ruler, I got 2.44. The vernier caliper, I got 0.46,
Okay.
and the micrometer 0.59.
0.59. 59. Okay, 0. Okay, good. So now work on the units, okay? Work on the units, and I'll get back to you in the next round.
Okay, thank you.
Welcome. And next here, Jacob Contreras. Not yet? Okay, so I'm gonna put N here. I'll get back to you later on. Next, Evelyn Ayala. Did you plot your 3 graphs, Evelyn? Evelyn doesn't seem she's here. Yeah, Evelyn is not here. Isabella Cisnero. I don't see Isabella either. Elizabeth Saldanha. I don't see Elizabeth either. Let's see. Next. Oops. Oh, Evelyn. Let's see. Evelyn is not here. Isabella is not here. Oh, Trin. Trin Hernandez. Is Trin here? I skipped Trin. Okay. And then the next one is Elizabeth Saldanha. Let's see. Elizabeth Saldanha is not here either. Simone is not here. Oops. See, let's see here. Oh. Anybody else? Here, 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 and here. Let's see if I have the right head count. We have 19 students, but I'm getting only 18 here. Oh yeah, I'm getting 19 because of Brando. Okay, good. So what time is that? That is 11:46. I think we can go for another break, right? Break 11:46 a.m. to 12:01. Any questions before we go to the break? Okay, I see you in 15 minutes. I am back here. Okay, so let's go back in the cycle here, right? Let's see, Eric. So did you manage to get all the percentage differences?
Yeah, I got 0.934 and then 0.999 and 0.987.
987. Okay, good. So they're all within reasonable values. Did you start working on the units already?
I haven't gotten that yet.
Okay, good. So let's go for Edith. Let's see. You plot out the graphs, Edith?
I'm like finishing up almost.
Okay. So, okay, I'll get back to you later on. What about Jawairia? Did you manage to finish all 3 graphs? Okay, okay. How many graphs do we have so far, Jawairia? Okay, I'll let you work that. No graphs. Do you have any problems plotting? Do you have Excel? Is there anything I can do to help you? Do you have any problems plotting the graphs? Can you tell me what's No. Okay. Okay, so let's go to the next. Arwa, did you plot all the graphs, Arwa? That doesn't look like Arwa here anymore. Let's see. Paris, yeah. Arwa left apparently. Let's see, Catherine. Catherine is here. No. Next, Ben Bandoy. Did you, okay, so you plot out the graphs, right? And now, last time I talked to you, you were working on the units. Is that right, Ben? Okay, did you finish all the units? Okay, so I'll get back to you later on. Let's go, Melissa. Did you plot out the three graphs, Melissa? Looks like Melissa is not in front of computer. Okay, let's go to the next one. Let's see, Delisha is
I'm here.
okay. So did you plot all the three graphs?
Not yet. My lab partner is gonna help me with it.
Okay, so how many graphs do you have so far?
I haven't started yet.
You haven't started yet. Do you have Excel installed in your computer?
Yeah, I do.
Okay. Okay, so try to finish it. Okay, and if you have any problems, I can help you. Let's see. Next one here is gonna be Isabel. Isabel is here. No. Queen Castaneda, are you there? Queen left, huh? Yeah, Queen left. Next one is Emily. Emily left as well. Okay. One more. Gabriela is not here. Carlo. Last time I talked to you, Carlo, you were looking at the percentage differences, right? Did you manage to calculate the percentage differences?
I did, but I got really high numbers for
Okay,
the
so
ruler
tell
one.
me.
For the ruler one, I got 13.27. For the Vernier caliper, I got 94.51. And then for the
94.51.
and then for the micrometer, I got 1.76.
1.76. So let me see. Vernier caliper, you got 94.51. Is that right?
Yeah, 94.51.
Okay, definitely there's a mistake here with the vernier caliper. Let's see what's the problem. Graph group number 6. Make sure you plot the right the right axis, right? I'm suspecting that you plotted the wrong one for the vernier caliper. Let's see what was the problem. Here we go. Here is group number 6 spreadsheet. Okay, I'm gonna plot the mass and the volume of the vernier caliper. It seems that the problem should be, and we do for the ruler as well. Insert, let's do for the vernier caliper first. Okay, so here you go. We have a straight line here. Does your graph look just like mine?
Oh, let me check. For which one?
For the vernier caliper. For the vernier caliper. Let's see. You are Carlo, right? Carlo Gallardo.
Yeah.
So see if your graph looks similar to mine. That's the first thing that you gotta.
Yeah, it does look like that.
Okay, so let's see. And I am going to get the slope. I'm getting
yeah, I
got
that
a
number
larger
too.
slope as well. Okay, so let me see what is the problem. Must be the data. Okay, the problem must be the data. 8 grams, the diameter. That's telling me that's 1 millimeter diameter. Yeah, those measurements are not correct. Yeah, see, definitely those measurements are not correct. So format
Oh,
cell.
okay.
Yeah, definitely something happened to the measurements here. 3,
Mm-hmm.
4. See, he's telling me that that the sphere has less than 1 millimeter, has 1 millimeter in the diameter. Okay, so and this one has less than 1 millimeter. So it looks like whoever collected data didn't do a good job. Uh, hmm, didn't do a good job with the decimal places here. I wonder. Let me delete just one decimal place here, and let's see if we get a better result. Okay. Sometimes we get those things. Okay, so that's why it's important for us to interact in the classroom, because sometimes we find those types of problems. Let's see what happens to the slope now. Okay, see,
Oh, is this the extra zero?
yeah, he put more than 1 0 there. So when he logged the data and he put an additional decimal place there. What about the rest? See the ruler? See, the ruler has a better measurement than the vernier caliper, right? So he looks like
Mm-hmm.
he screwed up only on the vernier caliper. So much that we have 10 to minus 2 here, right? 10 to minus 2 here. Yeah, so he screwed up only in the vernier caliper. Everything else seems to be
So the
okay.
ruler is correct, right?
Yeah, seems to be correct. Let's plot the ruler. Seems to be correct. Let's plot the ruler as well. Don't forget it's the volume, right? Insert. Let's see, trend line. I'm getting 8,948. So kind of a
Yeah.
high, but it's within the reasonable values for the ruler. Remember, it's very difficult. 13% difference, right? That's what you got?
Yeah. Yeah, I got that.
Okay.
I
So
think it's just the vernier caliper.
yeah, the problem with the vernier caliper is the decimal place there that he put
Oh, okay.
an additional 0 that he is not supposed to do.
Okay, I'll
So
fix that.
watch out for those things, okay? Those things happen in real life. Those things happen in real life. We log it incorrectly, okay? Not because we are dumb or you're stupid or incompetent, but because we sometimes get tired. And when we get tired, we make mistakes, okay? That's normal. That's normal. And that happens in every profession, okay? You are so eager to do the work, so eager to do the work that you continue working even if you are tired. And it can be, sometimes a mistake like that can be deadly, because if you are working, for instance, with nuclear energy, right? If you're working with a rocket to launch a rocket into space, something that can explode at any moment, if you're tired and working something dangerous, you don't want to overwork yourself, okay? Or otherwise you can lose your life. It's so take some lessons from this type of exercise that we do here in the classroom. Okay, so now 13%, good. So now you should be working with the units, right, Carlo? And
Yes.
okay, so Angelica, did you manage to work with the units? Did you finish the units already?
Not yet.
Not yet? Okay. So I'll get back to you later on. Princess, did you finish all 3 graphs?
I haven't yet. I'm looking at my second graph, but I feel like my y equals mx plus b equation, I think it's wrong. I don't know, like when I try to change the equation, it's like the number is too big.
Uh-huh. Okay, so you're group number 7, right?
Yeah.
Okay, so let's see what's the problem here. Which graph you're having problems?
The second one,
The second one, vernier caliper?
yeah.
Okay. So let's plot the vernier caliper graph. Oh yeah, let's see. Yeah, the numbers of the diameter doesn't seem wrong. Okay, they are all in the right order of magnitude, 10 to minus 2. So let's plot the mass. Don't forget, you gotta plot the mass and the volume, right? Sometimes I see students plotting the mass and the diameter. Sometimes I see that happening. And of course, they're gonna get the wrong graph, right? So make sure you plot the mass and the volume. Insert. Okay, the straight line. And let's get trend line here. Display. Okay, I'm getting the right slope here. See that? 8,029. Did you get this slope as well?
No, my slope is, I think mine is still in scientific notation. I got y equals 2e plus 0, 8x squared plus 6, 807.8x.
Okay, so tell me what's the value of the slope that you got. Can you repeat that, please? The value of the slope only.
The value, the y one or the r squared?
Yeah, the slope, this value right here.
So for the y, I got y equals 2e plus 0, 8x squared
0,
plus
8x squared?
0. Yeah, I don't know why it did that. That's why I was wondering if like my y equals mx is wrong.
Yeah, okay. So you have to share your screen with me, okay? Share your screen with me. Let's see what's going on there. Let's see here. Go ahead, share your screen with me. And I want to see your graph. What's going on there?
Okay. Can you see my screen?
Not yet. Oh, wait a minute. I have to stop sharing. Okay.
Oh, okay.
Okay, I didn't stop sharing. Okay, so let me see. Can you zoom in?
Oh, sorry. Let me reshare. I thought you.
Yeah, go ahead. You can share the screen.
Okay.
Now I need to zoom in because it's too small for me to see.
Sorry.
It looks like you. Okay, I know what the problem. Okay, you are not plotting a straight line there. You're not. Your regression equation is a square. Is a parabola. Okay, that's the problem. Okay, so you have to plot it again. So okay, stop sharing. I will reproduce here what you did. Okay.
Okay.
Okay, so here you go. It seems that your problem was the following. Let's see, someone is.
Dia inicial, mês inicial, final, ano.
Okay, so here you go. Mass and volume. Okay, that you did correctly. But then what seems the mistake that you made? Okay, you click the points. Yeah, you did click the points. You right click the points. Yes, you add the line. But what did you do? It seems that you put a power of 2 here instead of the linear. Okay. It looks like you use this graph here. Display equation graph R square. See that? Must be the same thing that you got there, right? Double check there. Okay. So do you see what was the problem? You have to
I guess so. Yeah.
Okay. You have to use the linear fit.
Okay.
Linear fit. Okay. And now when you use the linear fit, you get the right result.
Okay. I see it now.
Okay, so yeah, the problem is right in here. You click in the polynomial instead of the linear.
Okay.
Okay.
I see. Thank you.
So you should be able to fix that easily. And let's go to the. We're talking with Princess, right? So Brandon, let's go for Brandon now. Brandon is not here, right? Don Guerrero.
Rotina mensal.
No, Brandon Guerrero is not here.
Excel.
Next, Janie. Janie, you gave me last time you gave me the percentage differences, right?
Yes, I actually fixed it.
And now my percent difference for the first one was 12.78.
Okay. Okay, so what was the problem that we had before that we're getting such a high percentage difference? Do you know?
I think it's like I plotted it wrong, like I got some of the wrong numbers.
Uh-huh.
So then now I fixed it and it looks better.
Yeah, okay. Okay, your group number 8. I think I plot the graph right when let's see, we are getting how much percent? We're getting 16%, right? Yeah, that's what you're getting now, right? 16%?
I got 12.78.
12.78. Your group number 8. For which instrument? The vernier caliper, the ruler, or the micrometer?
For the ruler.
For the ruler. So
Yes.
let me see. I'm getting 16% for the ruler. You're getting a different value. What is the slope that you're getting for the ruler? Are you getting 9162?
I am getting 89.04.
8909. Yeah, you're getting a different slope than me. I do not know why, but your group number 8, do you think you changed or you accidentally changed your data? That's one possibility. Yeah, but that's okay. It's still a small percentage. It seems that somehow your data changed along the way. Okay, but you plotted a straight line, right? A linear graph, just like mine.
Yes, my graph looks like yours.
Yeah, it's just the slope that's different for some reason.
Yeah, it's just a little different because yours is 91.62. Okay, so it's like
Yeah,
like 20 off, I think. It's like 20 off.
yeah, 9162. Mm, okay, yeah, I'm curious what's happening. Share your screen with me. Share your screen with me. Let me see. I can figure out why this difference here.
Okay, give me 1 second. Um, Let me share. Share my screen.
Okay, that's okay. So show me the one for the ruler. Which one's the one for the ruler? Should be the top one, right? And you click one of the data points in one of the graphs. Ruler 89.
Sorry,
Yeah.
there's a plane passing by, so I muted myself. I'm sorry.
Uh-huh.
Uh,
Click one of the data points. Let's see.
so
Now,
I did or let me I'm sharing. I did my graphs on Excel and then I plotted them in here, but
uh-huh.
I can just
Oh, it looks like you're okay. It looks like you're using a different. Yeah, Are you using Google? Yeah, you're using Google Sheets. Okay, that's why.
yes.
Okay, so it happens. Google Sheets. You might be using that online, right?
Yeah, because I copied the same exact numbers on Excel and I made the graph on Excel, but let me see if I can make it on here. Because we're using these values, correct?
Yeah, that's right. Uh-huh.
Okay, let me see if I could create another one.
But if you use Google Sheets online, it's not gonna work properly. Okay, so go ahead, click one of the data points. Let's see, and right click.
Mm, right click, grid lines, no. I'm sorry. It's like I'm more used to using Excel. So
Yeah,
like
yeah.
it's a little weird for me.
You're better off plotting this graph directly from your laptop, from your hard drive, because when you use Google Sheets online, it doesn't behave properly. Okay, it doesn't behave properly. I had this experience before.
Let
So
me let me try and share my screen of my Excel because I don't, let me see. I don't know where. Let me stop sharing this one and then I'll share my other screen.
did you download the spreadsheet to your hard drive?
Yes, I did.
You did?
So
Okay, so 89.
so this is what I have.
Let's see here. That's for the vernier caliper?
For this one is for the ruler.
For the ruler.
For the
Okay,
ruler.
so let's see if we have the same numbers. It looks like we have the same numbers. Let me see one thing. I think number. Yeah, okay. I know what's the problem.
Mm-hmm.
Yeah, I know what's the problem. When you copy your volume data, you use just the first significant figure. That's why we're having this small difference. Okay. Okay.
Okay.
See the number that you see the number for the volume, 4 times 10 to
Yes.
minus 7 is actually 3.8 times 10 to minus 7. Okay.
Oh,
Okay.
okay.
The third one, 2 times 10 to minus 6 is actually 1.77 times 10 to minus 6. Okay. That's why you're getting a slightly different value than the one I'm getting. Okay.
Okay.
Because when you type it, the values for the volume, looks like you type it, you didn't type all the numbers there. Okay.
Okay.
That's why. So try to fix that. Okay, and again, don't work with Google Sheets. Don't work with Google Sheets. Work with Excel in your hard drive. Everything directly from your hard drive, and you'll be okay. You do everything fine. Okay.
Okay, thank you.
Okay. Let's go. Let's see. I just talked to Jenny. What about Kimberly? Kimberly Morales. Oh, I have to share my screen, right? Okay, using phone today. Okay, so did you last time I talked to you, you had plotted 2 graphs like Kimberly? Did you manage to finish the third graph? No? Okay, so you said that you're just using your phone, right? You don't have your computer. Is that what's happening? Okay. Yeah, make sure you have your computer, right? Because nobody will be able, it's kind of impossible plotting the graphs with the phone, right? Make sure you have your computer next time, okay? Let me write that down here. Cell phone, and no computer. Montserrat, is Montserrat here? Montserrat is not here.
Excuse me, sorry, Professor. I just had a question.
Uh-huh. Go ahead.
So for the slope units, is it just like m over kg?
The slope should be the unit of the mass divided by the unit of the volume. Okay? The unit of the mass divided by the unit of the volume. What is the unit of the mass? Okay.
The mass is the scale, right?
Yeah, and what's the unit do you use for the scale?
Kilograms.
Yeah, that's right. Here you go, kilograms. Now, what about the units for the volume? You know what?
Meters
Huh?
or Sorry, what'd you say?
What is the unit for the volume?
Meters?
No, it's not meter. Meter is the unit for the diameter.
I don't know.
Yeah, the meter is the unit for the diameter, okay? You in order to find out the unit of the volume, you gotta look at that equation that I wrote down here, right? Here you go. See the equation here? Right? I'm going to, if I do the math, I get 1/6 pi d to the cube, like that, okay? Here you go. Oh, 1/6. Why did I put 63? 1/6. Okay. Now you have to do the dimensional analysis of this equation. You know, if you had only d here, if the equation were like that, which is not, then the unit of the volume would have been meter. Okay. If the equation were like that, but the equation is not like that. The equation is like that to the cube. Okay, because the diameter is in meter and you are cubing the diameter, the unit of the volume is going to be what? It's going to be cubic meter. Okay, it's going to be cubic meter. Right in here you go. Unit of the volume, cubic meter. And I can even do the something like that. Here you go. Did you get the idea? Okay, you gotta do the dimensional analysis of the equation. Okay. The ones and the 1/6 and the pi, they don't have any units whatsoever. The only thing that has a unit is going to be the cubic meter. The cubic meter, the cubic diameter, which is equal to d, like that. The unit of the diameter is the meter. This guy is gonna be the meter, and then you have the cube raised to the meter. Okay, that's how you solve this problem. And now you have the unit of the mass, right? Here you go. Unit of the slope. Unit of the slope is the slope I'm going to represent by the letter rho, okay? Unit of the slope. The slope we usually represent by the letter rho, like that. The slope is the mass over the volume, okay? And the unit of the slope we write as unit of the mass divided by the unit of the slope. The mass divided by the unit of the volume. The unit of the mass divided by the unit of the volume, right? Go. The unit of the mass is the kilogram. The unit of the volume is the cubic meter. That was the rise over run. Unit of the rise over the unit of the run. Okay? Any questions about that? Let's see. Montserrat is not here. Nicholas is not here, right? Jason, did you finish all 3 graphs, Jason?
I'm still working on it right now.
Yeah, you're still working. Do you have any problems that you need help? Do you need any help with the graph?
I think I think I'm good right now. I'm just like referencing to past lectures.
Mm-hmm. Okay, so
Yes.
you think you got it, right?
Yes, thank you.
Oh, okay, so when you finish the graph, make sure you log the slopes, right, in the last table. Kimberly was asking for the cubic meter. Yeah, cubic meter is the unit for the volume. Okay, Kimberly? 425. And let's see, Sydney. Sydney is not here. Armand, are you there, Armand?
Yeah, I'm here.
Okay, did you finish all the three graphs, Armand?
Yeah.
Okay, good. What was this? What was the percentage difference you get for all the three graphs?
So I did it on Google.
Yeah.
But then I guess the issue is it's hard, like I can't get the right. All it's giving me is the R2, which is the 0.989 for the
Yeah,
um
yeah. I tell my students not to do in the Google Sheet
yeah,
because it's
I'm doing it on Excel
probably.
now.
What's the problem?
I'm doing it on Excel now,
Oh,
but
you're
it's
doing
not
an Excel now. Okay, okay. If
but
you do an
now
Excel,
but, but now when I'm trying to do the command and then I'm getting just the two informations, it's not letting me create a chart with just the two like the kilogram and the volume.
okay. You have to share your screen with me so I can see what's going on, right? Do
Okay.
you have Excel installed in your computer?
Yeah.
Yeah. Okay. So go ahead, share your screen with me. Let's see what's going on there.
So this is the Excel one because I'm transferring it over. And like
Okay.
when I'm selecting,
Yeah. Select. Okay.
and then
Now
I
insert.
insert
Yeah,
scatter
that's the
plot,
one. That's the one.
this is
Uh,
what comes up.
Wait a minute. Right, there's something wrong. Yeah. Okay. Delete. Are you using Mac?
Yeah.
Okay. Okay. So let's see. Click again. Insert. Click insert again. Top left. Let's go slowly. Let's go slowly. Oh. To the right. This one. Click down. Yeah. Click down.
This is what I clicked. I just clicked this one.
Yeah. But I don't see the graph showing up there. Go.
But I click this what happens.
What? Why is that?
That's
Uh,
my
huh. Strange. Yeah, really strange. Let me see what's going on there. Yeah, let's see.
like I'm going through the settings. I'm trying to figure out, so I don't know.
It is possible. Let me see. Why don't you change the format of those numbers? Let's change the format of those numbers. Delete the graph. I have seen this problem before, and sometimes it's solved by itself. Highlight the graphic, highlight the again. Let's do different. Highlight the volume of the micrometer and the scale. Okay, let's do like that. Those two, yeah, those next to each other. Just drag to the right. Yeah, good. Now go again there. Insert. Go slowly. I want you to click on the arrow down first. Click the arrow down first.
Yeah.
Okay. Yeah, the arrow down. I don't see. You click. Did you click the arrow down?
On this? Yeah.
Yeah. But you click the arrow down, but I don't see the graph showing up. Click.
It's showing
It's showing.
it's showing
Yeah.
for me. It shows scatter plot or bubble plot, and then it's
Yeah.
showing
It's
like
scatter plot. You want scatter plot? Yeah. It's not
yeah.
showing for me. For some reason, it's not showing for me. Okay. Highlight and click. Let's see
Okay.
what happens. Yeah,
Yes.
again. I do not know what's happening there. Must be something related to the Mac.
I don't
Uh,
know. I was gonna have to Google it. I gotta figure it out.
yeah, see if you can try. Let's see. Let's build a table, a separate table on the space to the right. Put X and Y, just like we did before, X and Y, right? X in one column. Just write down Y in the other column and put 1, 2, 3, 4 below them. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now put 2, 4, 6, 8. 2, 4, 6, 8. Now plot this graph. Let's see. Highlight those two. That is okay. Go to the insert. Click it.
It says some chart types cannot be combined with other chart types.
Huh. Select.
Yeah, weird.
Okay, maybe you click the wrong chart.
No, I clicked the scatter plot.
Huh. Okay. I don't know what's going on. Make sure that you have Excel installed in your hard drive. Okay, that's the only thing that comes to my mind. It's not working. Did you install it in your hard drive?
Yeah.
Yeah. Okay.
I have to probably Google it. I probably have to watch like Google it and figure it out. There's probably
Yeah, it shouldn't be doing that. Even the Mac shouldn't be doing that. Okay, that might. Oh, wait a minute. I see. Unclick. Yeah. Okay. But don't highlight all of that. Highlight only the cells. You start at the X. Yeah. Here you go. Only this. Now go. Yeah, go there. See, it doesn't show in my screen for some reason. Ah. Huh. Yeah. So strange. Let me see. Let's try one more thing. Delete this chart. Delete this chart. Highlight those numbers. Highlight those numbers, all of them. Right click. Right click. We're gonna check out. Yeah, you don't, but keep them highlighted. Now format cell. Format cell. Let's see.
Okay.
Scientific, put numeric format number. The second one from the top to the bottom. Okay. Put 2 decimal places just in case. There's no need to do that. 2 decimal places. Good. Now click OK. Okay, now plot them again.
Like
Right click.
okay.
Did you plot it?
Like create the are you talking about create the chart again?
Yeah, insert. Insert. Yeah, it's still not working properly. Yeah, I do not know what's happening. Is something there in your computer? But make sure that you have Excel installed in your hard drive. That's the first thing that comes to my mind. Okay.
Yeah,
that comes to my mind.
Installed. I don't know. I gotta search it up.
Yeah. Okay. So let's go to the next student. Now, if you may stop sharing the screen, please.
Yeah.
Let's see Zoom. I'm gonna share my screen here. And Armon, right? Juan Torres Arellano. Are you there, Juan? I don't see Juan. Looks like he left. Cecilia Chavez. So last time we talked, you told me about the percentage difference, right, Cecilia? Are you there? Okay. Juan Torres Arellano. Oh, Juan Torres is here. Okay. So you're still working on the third graph, okay? Okay. So are you having any problems plotting the graph, Juan? Is there anything that I can do to help you finish all the graphs? Yeah. Well, it looks like Juan is a little bit slow down. I'm figuring out right now. Okay. Okay, thank you. Let's go for Cecilia. Cecilia, can you hear me? Cecilia is not.
What was the question?
Yeah, hi, how are you doing? Okay, so you finished the percentage difference, right? It looks like everything is fine there. What about the unit?
Yes.
Did you finish the units?
No, I'm still trying to figure out the formulas to solve for stuff.
The formula for what?
Well, I'm stuck on the, one second. By the units, do you mean like the n equals m equals and the r squared?
Okay, let's go slowly here. The unit. The unit is, you can see here the unit for the density is kilogram per cubic meter, right?
Oh, yeah, yeah.
Okay. Now you have to fill up those ones here. Did you fill up those ones here?
Yeah.
Okay, so next, right? Next, the slope here. Did you fill up? You already.
Yeah, I have the
And now
slope and the percentage difference.
exactly. And the units here, the units of the slope, the unit of the slope is exactly the same unit as the density. Okay?
Okay.
That's what the unit of slope is all about. Is the unit of the kilogram divided by the unit of the volume.
Okay.
Okay, so you have to do copy and paste here. And then you do the same for the percentage difference. Percentage difference, you're gonna use the percentage sign. Okay? That's the unit of difference. Okay, so let's see here. Format, font, strikes through. Okay. So let's see. And in addition to the units, Cecilia, then you will need to work on after the units. What do we have to work on? After the units. Fill up the units. Next, you have to display the proper number of significant figures, right? That's what you have to do next. So once you finish the units, make sure you start displaying the right number of significant figures right here.
Okay.
Okay? Here, here, and here. And we go for Jacob. Jacob is there. Oh, you have 5 more minutes to go, right? 5 more minutes to go. Let's see. Jacob. Oh, yeah. Jacob Contreras. Are you there, Jacob? I'm not hearing from Jacob. The other students are not present. So let's start from the top, right? Restarting here. Eric, did you finish the unit? I think Eric's here. Yeah, Eric seems to be here. I can't hear from Eric. Let's
He
go
said
to
he's still working on it.
I should work on it. Okay. What about Edith?
Professor, I actually need help with the graphs because I don't think my formatting is correct.
Okay. Are you using a Mac or a Windows?
A MacBook.
A Mac. Okay. Did you install Excel in your Mac?
Yes.
Okay, you did install Excel in your Mac. So why don't you go ahead and share your screen with me? Let's see what's going on. Okay. Okay, so let's see. Show me you plotting the mass. Let's do from scratch, everything from scratch, right? Your group number, which group number are you?
Number 1.
Number 1. Let me get your spreadsheet as well so I can follow with you. 3 more minutes to go, right? We're running out of time here. Let me see. Go ahead, highlight. Delete this graph for now. Delete this graph for now. Good. Now, go ahead, highlight the mass values? The mass, not the diameter. That's the diameter. The mass, yeah, here you go. Good. Now highlight the volume of the ruler. No, okay, you're doing wrong. You're doing correctly, okay? So go ahead, highlight the volume again. The volume first the volume. Good. Yeah, good. Now unclick the mouse, good. Now press the command key in the Mac. Press the command key in the Mac. Okay, now highlight the mass.
I think you meant shift, correct? To highlight both?
Let me see what's going on. Let's do it again. Command key. Now, see, if you do that, you're highlighting everything, right? So that's why you have to click the command key. When you click the command key, you're going to highlight only those two columns alone, okay? So let's do that again. Volume, highlight the volume. Good. Unclick it. Unclick it. Now go to the mass. Press the command key. Oh, you gotta press the command key. You didn't press the command key, okay? Let's do it again. Highlight it. Unclick it. Now go to the but you click it, okay? When you click it, you unhighlighted it. Okay, so let's do it again. Highlight the volume. Good. Unclick it. Move to the mass. Take it. Good. Now command key first. Did you click the command key? Okay, now highlight the mass, the values of the mass. Click them. Something is happening there in your Mac. Why is not so strange? Yeah, let's do easier. Let's do simpler than that. Instead of the ruler, let's do the volume and the mass, the micrometer and the mass. Volume of the micrometer and the mass. Yeah, okay. Now insert. Go to the graph, right? Down, yeah. Add XY scatter. Not this one. To the right, this one, XY scatter. Click it. Did you plot it? I don't see it plotted yet. Okay, see, now you got it. Let me see if I can get the same one. But we're doing for the micrometer, okay? We're not doing for the ruler, we're not doing, let me see. Yeah, my graph looks just like yours. Now click one of the data points. Click one of the data points in the graph. Good, right click now. Right click. Add trend, let's see, add trend line. Go to add trend line. No, not scan document, add trend line. Good. Now you have linear, click it there to the bottom of the pane. We see display equation on chart. Display R square value on chart. Okay, so what you're getting there for the slope, 7846. Okay, so let me see if I get the same thing. 7846. I'm getting exactly the same. Okay, so we successfully plot the mass versus volume for the micrometer. Okay, now you have to figure out how to plot the mass versus the volume for the ruler and the vernier caliper. Okay, for some reason we were not able to do that, but you have, the way to do it is to click on the command key in the Mac. Okay, but for some reason it looks like it's not working. Let's see. Yeah. For some reason, it's not working in your computer. Are you clicking on the command key in your Mac?
Yeah. Do you want me to press and hold on it or just to click on it
press and hold it. Press and hold it. You have to press the command key and hold it. Okay, now see, you have to press and hold. It looks like it highlighted everything, right? Did it highlight everything?
I think.
Let's see if it's gonna plot. I don't see everything highlighted there, but let's try it anyway.
Oh.
Yeah, there is you have to figure out how to plot that in the Mac, okay? Let's see. I'm gonna give you another, yeah.
Oh, you have to individually click on it, I think.
Yeah, that's what there might be a better way. Let's see if it works. Let's see if it works. Yeah, it doesn't work. Okay, let's try something else. Let us try something else. Okay, I'm gonna display the screen for you. You can delete this chart. Delete this chart. Let's see. We have. We burn out the time already. But let me spend a few more minutes with you. Maybe this one is gonna work. You're group number 1, right?
Yes.
Okay. Now stop sharing. Let me share the screen with you. We're gonna try something different that may work for everybody else. Share. Okay, here you go. So must be a problem with the Mac. Okay, we are going to do the following. We are going to copy this volume for the ruler. Okay, see that? Highlight and copy. Okay, and then what you're gonna do? You're gonna paste them right here to the right, but they're gonna paste it in a different way. How are you gonna paste it? You're gonna right click and you choose this paste option, values, numeric values. Okay, and you do that, and then you do the same for the mass. Copy and paste. Okay, and now you highlight and plot. Now that should solve your problem. That should solve your problem. Okay, for those 2 students, right? For every student that has a Mac that you're having a problem plotting it, do something like that. Copy your volume, but then you paste, you do a special paste. Okay, you do one value, paste just the value, numerical values. And then you highlight those 2 columns and then you plot your graph, mass versus volume, okay? Okay, let's stop here and any more questions? Anything else that you want to share with me? I'm going to stop sharing here my screen. And did you try to do that, Edith? Were you successful?
I tried to do the special pasting, but it didn't it didn't paste it on to the other side.
Yeah. Okay, so
yeah.
Okay, so the other option is just to type the data manually. Okay, just type the data manually, and that's what I suggest you do. My office hours, Jawaira, is on Monday after the class, 12:50. Okay, Monday after the class.
Professor, when is this lab due?
It's gonna be 2 weeks from now.
Okay.
This lab is due 2 weeks from now.
And the lab is you're looking for the charts, right?
Yeah.
That's the lab. You're looking for us to plot these charts, and that is considered our lab.
Oh, it's not just the chart, right? There are other things too. You have to fill up the tables, right? You have to plot the charts, fill up the tables. Let me share the screen with you. Here you go. The chart is just one part of what's doing the lab. Here you go. Plot mass along the y-axis, v along the x-axis. Log the slopes of each graph. Items 1, 2, 3, 4, and 5. See that? All of that is part of the lab. All of that, you have to fill all the stuff in the spreadsheet.
Right. So, but what I'm saying, sorry, I guess that was a little confusing. What I'm saying is everything in the spreadsheet that you're showing us right now is what is part of our lab that's due in 2 weeks.
Nothing else. Just the spreadsheet.
Nothing else. Just that.
Nothing else. Just the spreadsheet.
Okay. And then the exam is due when, or when are we doing the exam? Sorry.
Okay, it's gonna be 2 weeks from now. Here you go. Let's.
So both the exam and the lab are due at the same time.
No, lab report. Here, I'm gonna type here. Exam 1 is October 8, 25, next week, right? Exam. Lab 1 report due October 15, 25.
Okay.
Okay? 2 weeks from
Got
now.
it.
October
And
5th.
Professor, can you explain how you do the exam? I know you said you do it it's on Zoom and we have to have our camera on and things like that. But can you explain, are you putting problems up on your computer to show us how to do, or like, can you explain how the exam process works?
The exam questions are going to be similar to the homework questions. Okay, let's write it down here.
Oh,
Exam
okay,
questions
perfect.
similar to homework questions. Okay, and they are all and you must have access. You must have access to Canvas. Okay, they're all on Canvas. All the questions are in Canvas.
Okay, so the exam is on Canvas as well then.
That's
You just
right.
want our Zoom on video. Okay.
That's right. But I need, it's written down in the syllabus, right? Here you go. Homework questions, and the exam will be in Canvas. Okay, you must have access to Canvas. During the exam, you must have access to Canvas and be logged in to Zoom in this address with your camera on. With your camera on. With your camera on. Okay?
Okay, thank you, Professor. That explained it.
Okay. So let's see. In our first test, next one is going to be on Zoom. Yes, the test is going. You must be on Zoom, and the test is going to be on Canvas, but you must be logged in Zoom. Okay, Jaguaira? Okay.
Professor, what if I can't make those times because usually when your class is happening, I'm at work.
Oh, yeah.
I
exam.
took the day off.
Yeah, you must take your time off from work to do the exam. Okay, you gotta do
Is it possible to make it up or like at a different time?
No,
And how long does it take?
2 hours.
2 hours. Okay.
Okay.
Thank you.
Professor, I have
yeah.
a question. Are we allowed to use notes?
Oh,
on
yeah.
the test?
Open notes, open book. Open notes, open book. Okay.
Thank you.
Let's take a look. Let's take a look here at the syllabus, right? Here you go. If you search open notes, right? Open notes. Here you go. Exams are open notes, open book. But you cannot get outside help from anybody. Okay? Right in here.
I have one more. Is it multiple choice?
No, it's gonna be numerical, and that can be multiple choice questions, yeah. But most of the questions are going to be numerical questions. You're going to need your calculator to do the calculation. Calculators or Excel, okay, to do your calculations and type your numerical results there in Canvas. It's possible, right? It's possible that I put multiple choice questions. It is possible, but most of the questions are going to be numerical. Any more questions?
So most of the questions, will they be like calculating something or?
Yeah. If you're doing the homework, you're gonna have a better idea of what the questions are going to be. Okay. For instance, I can give you an equation of motion, right? X equal to whatever. Calculate the position of the object at t equal to 4 seconds. Okay. Okay. And that was gonna be. What are the timings? What do you mean by timings? Time off.
I'm not for the exam. Would it be the same timings as the usually how the class is?
Yes, the exam starts at 9:40, and let me see. Let me see. Right in here. See that? Partial exam. The partial exams will be on Wednesday from 9:40 a.m. to 11:40 a.m. But just for the partial exams, okay? Let me highlight it. The final exam is different. The final exam is going to be between 9:10 and 11:10, okay? Well, let me
Oh,
put
that's
it.
not a problem. Yeah, that's fine. It's fine. Thank you.
Okay. Put that in red. Anything else?
No, that's it. Yeah, because I have to ask for time off, which I mean I can do. Not an issue.
What do you mean time off? I don't understand.
I have work. When I have your class, I have work. So I'm able to do the labs, but obviously during the exam I can't do that. So I will, yeah.
Yeah, you have to choose. Okay, the exams are set up at this time. Okay, and you have to choose which one is more important for you. It's not every
Yeah, I
day
know. I
you do
get.
that.
Yeah.
Okay.
Thank you.
Anybody else? Okay, so I see you next Monday. Okay.
Thank you.
Bye bye.
Thank you, Professor. Have a nice day.
You too. Bye bye.